To build the perfect glass vessel, start with the earth itself. We are looking at thousands of tons of...
But the secret ingredient is cullet, recycled glass. It saves huge amounts of energy and lowers the melting point required in the furnace.
It's chemistry on a massive scale. If the recipe is off by even 1%, the final glass will be brittle or simply won't melt correctly.
The batch house weighs the mix with digital precision. Now, the raw cocktail rides the conveyor.
The furnace, a beast that runs 24/7 for over 10 years, burning at temperatures that rival the inside of a volcano.
Inside, at 1500 degrees Celsius, the solid world surrenders. Sand turns to liquid, dissolving into a river of molten light.
Operators monitor the throat temperature from a safe distance. The glass must flow like thick honey. Consistency is absolutely key here.
Bubbles must rise to the surface to escape. This refining process is crucial. Trapped air now means a shattered bottle later.
The molten glass leaves the furnace and enters the forehearth. It's cooled slightly, conditioned to a perfect thermal homogeneity.
Here comes the cut. Mechanical shears, timed to the millisecond, snip the continuous stream into precise burning slugs called gobs.
Each burning slug is the exact weight needed for one single bottle. No more, no less. Gravity takes over from here. The distributor acts like a traffic cop, firing the gobs into different scoops, racing them toward individual molds at high speed.
They slide down lubricated chutes, accelerating to nearly 100 miles per hour. They are desperate to become bottles.
Welcome to the IS machine, the heart of the factory. It's a loud, hot, mechanical marvel of total synchronization.
The process has two stages. First, the gob drops into the blank mold to be formed into a rough, hollow tube called a parison.
The mold clamps shut. Compressed air or a plunger blasts into the gob, pushing the glass against the cool iron walls to form the neck.
Then, the flip. The arm inverts the parison, transferring it to the blow mold. It hangs by its neck, ready for the
The mold opens, revealing the newborn bottle. It's solid enough to stand, but still red hot and soft enough to dent.
Final blow. Air is injected again, forcing the glass to expand fully into the shape of the bottle, beer, soda, or jar.
Gentle iron hands lift them out. They pause on a dead plate for just a second to harden the bottom skin before moving on.
A sweeper arm nudges them onto the main conveyor. Now they join the march. A glowing army of orange glass.
At this stage, the glass is incredibly vulnerable. The surface is pristine, but microscopic scratches now would ruin its strength.
That's why they get a hot end coating. A thin layer of tin oxide is vaporized onto the glass to protect the surface.
This coating acts like a primer. It helps the final cold coating stick later and prevents the bottles from scratching each other.
The bottles are cooling unevenly. The outside is cool, the inside is hot. This creates stress. If left alone, they will shatter.
They must enter the lair. It reheats them to a uniform temperature, then cools them down very, very slowly to relieve stress.
This process takes about an hour. It aligns the molecular structure of the glass, locking in the durability.
While the bottles nap in the tunnel, the factory floor keeps moving. This massive oven can hold thousands of bottles at once.
Before they touch, they get a cold end coating. A layer of food-safe polymer wax is sprayed on to make them slippery.
They emerge at the cold end. The fire is gone. They are now room temperature, rigid, and ready for the world.
This lubricity is vital. It allows the bottles to slide past each other in high-speed filling lines without jamming or scuffing.
Now the army reorganizes into single file. They are about to face the toughest critics in the building, the inspection machines. Human eyes aren't fast enough. We use machine vision. Cameras and lasers scan every bottle at 600 per minute.
First, a physical probe dives into the neck to ensure the opening is perfectly round. If it's tight, a cork won't fit.
High-speed cameras look for visual defects like bubbles or stones, unmelted raw material. These are fatal weak points. Next, sensors measure glass density. If one side wall is too thin, the bottle could burst under carbonation pressure.
Don't feel bad for the rejects. They aren't trash. They go right back to the start to be melted down again. The circle of lie.
Fail any test, you're out. A reject arm kicks the flawed bottles into the cullet bin with ruthless efficiency.
Only the survivors move forward. The perfect clones. Identical in weight, shape, clarity, and strength.
The single file line ends here. The bottles flood onto a massive accumulation table, gathering for the final stack. Physics takes over. Vibration shuffles them into a honeycomb pattern, the most efficient way to pack circles closely.
Enter the palletizer robot. It lifts hundreds of bottles at once, an entire layer, using suction or grippers.
It places the layer onto the pallet with delicate precision. Then, it places a cardboard separator sheet on top.
Layer by layer, the tower grows. A single pallet can hold thousands of units and weigh over a ton.
Once full, it needs armor. The stretch wrapper spins the pallet, cocooning it in thick plastic for stability.
Heat is applied, shrinking the plastic tight. This locks the load together for the bumpy truck rides ahead.
A forklift scoops it up. From a pile of sand to a packaged product, the journey inside the factory is complete.
But before they leave, we have to prove they are perfect. We head to the quality control lab.
We slice them open to measure glass distribution. We need thick corners and bases for durability.
Welcome to the torture chamber. We pull random samples every hour to destructively test them.
Under polarized light, invisible stress lines show up as rainbows. Too much color means the annealing failed.
The impact test simulates a bottle being knocked against a bar counter. It needs to survive the real world.
We pump water inside until it bursts. A good bottle withstands internal pressure far higher than any soda can create.
The mouth is measured to the micron. If this is off, your cap won't seal and the drink goes flat.
Every test is logged. If a defect is found, we can trace it back to the exact mold and minute it was made.
Quality verified. The lab gives the green light. The production line keeps rolling. The unsung heroes are the molds themselves. Cast iron shells that take a thermal beating every few seconds.
They get dirty with carbon buildup. They must be blasted clean and polished to a mirror finish regularly.
That logo on your bottle, it's engraved here, in reverse, right into the iron with high precision.
Changing molds is like a Formula One pit stop. The machine pauses, hot iron is swapped, and we are back running in minutes.
And down below, the basement collects the fallen glass and water to be recycled back into the system.
The infrastructure above is complex. Massive amounts of compressed air and vacuum lines feed the beast below.
It takes a village. Engineers, mechanics, and operators working in shifts to keep the furnace fed.
Night falls, but the factory glows. The furnace cannot stop. If it cools, the glass freezes and ruins the facility.
The warehouse. A cathedral of inventory. Millions of bottles wait here in the dark for their turn. From amber beer bottles to clear juice jars, every color and shape imaginable is stored here.
Distribution day. Trucks line up to take the glass to bottling plants, where liquid finally meets the vessel.
They are loaded tight, no wiggle room. A shifted pallet in a moving truck is a disaster.
These bottles will travel hundreds of miles, ending up in fridges and pantries around the world. The factory's job is done. The bottle is ready for its purpose. It's not just a container. It's an engineering marvel that costs pennies to manufacture.
Thanks for touring the line with me. This is modern manufacturing at its finest.
Sand to liquid.
Liquid
to shape.
Shape to stone.
The cycle of glass is complete.
If you found this satisfying, smash that like button. Comment below. What factory should we visit next?